Today's notes are going to be focused on graphing from a word problem. And every time we're going to graph, we always start by identifying two things. So we are going to identify the slope and the y-intercept. If we know those two things, we can represent that linear relationship in a variety of ways. We could make a table, an equation, we could make a graph, and we could also answer a variety of questions. Our first problem today is 3 kids in a scooter moving company charge $10 per hour and a scooter rental fee of $4.50. So first we want to identify the important information in our problem. I see they charge $10 per hour, and then we also have that scooter rental fee of $4.50. When we're given information in a word problem, we still start by identifying that slope and y-intercept. We just have to figure out which is which. The $10 per hour, because of that word per, it tells us that it's a rate, which is, remember, another way of saying slope. So our slope is going to be 10. Then we have the scooter rental fee of $4.50. That's a one-time fee, so that's going to be how much it costs initially, or that y-intercept. And once we know that information, we can write our equation. Y equals 10x plus $4.50. Y equals mx plus b. But when we graph, there's quite a few pieces of graphs that we have to remember. The first thing all graphs need are labels on our axes. And remember, those labels are going to be related to the problem. And it's going to be really helpful to look at that slope. Our slope is $10 per hour. This is my y value. This is the x value. So right there are my labels. Hours are x's, and money is my y. So across the bottom, we'll put hours, and on the side, we'll have money. Now that my graph is labeled, I can go ahead and number my scale. So I can see I have 10, 450. I don't really know points that I'm going to put on here, except I know I have that point of 450 for my starting piece. Then I have to increase it $10 every hour. So sometimes if we aren't sure, we can always build a mini table. So over here, just really small, I'm going to build a table for x and y. If my cost is 0 hours of rentals, I'm going to pay $4.50. 1 hour puts me at $14.50, and 2 hours puts me up to $24.50. So when I think about my scale, when I'm labeling that for hours, I can easily count by ones, but I want to spread it out a little bit, so I'm going to skip every other line. So I'm going to say 1, 2, 3, 4, 5, and 6. Make sure you count consistently. I said 2 lines were 1 point, so another 2 lines would be my next point, another 2 for my next, and so on. So making sure that's nice and even. Up the side, my y's are growing quite fast, but I still need to make my scale consistent. So maybe I count by 5. So if this is 5, 10, I'm not going to write every number though, because it's going to get really crowded. So I'm going to say each line is 5, but only write every 10. So we have 10, 20, 30, 40, 50, and 60. So each line is representing $5. And that's going to make it a pretty decent sized graph, taking up our space, but not being so cramped that we can't see. The one issue is my first point is the point 0, 450, so we will have to estimate a little bit, but that's okay. So I can start graphing now. So I have 0, 450, which is right close to 5. After 1 hour, we figured out it was 1450, which is right there. After 2 hours, it was 2450. 3 hours would be 3450. 4 hours, 4450. 5 hours, 5450. And that's all that I can fit. Now that I have points, I can go ahead and connect them in that nice straight line, arrows on both sides to show it goes on forever and ever. And there we have it. If we would have done something wrong, we wouldn't have a straight line. A straight line proves it's that linear relationship, which is what we're focusing on right now. And our next question says, Miss Kennel is starting a spring break fund piggy bank. And to kick off her savings, she puts in $20, and then each week she adds $1.50 in loose change. So I see I put in $20 for my starting point, and then each week I add $1.50 in change. So I'm able to identify my slope and y-intercept. My slope, remember, is that rate. That's going to be something that happens regularly repeated, so that each keyword is really going to help us. $1.50 in change per week. So I have my rate. I also have that y-intercept. I put in $20, my starting point of 20, and then I can go ahead and write that equation. Y equals mx plus b, y equals $1.50x plus 20. Now, just like in that last example, I find it helpful to build a little table to think about what kind of values I'm going to put on my graph. After 0 weeks of savings, I already have 20 bucks in there. After 1 week, I'm up to $21.50. 2 weeks, I'm now up to $23. 3 weeks, $24.50. 4 weeks, $26. So when we think about this now, unlike the last problem that went up pretty significantly each week, I'm going up really small. So my y values are all really cramped together, but they start at 20. My x values are not so cramped, but I still have this y value starting at 20. So it's going to be a little different when we scale this. So looking at my graph, I know that my labels can be pulled from that slope if I'm unsure, because the y values are on top, x are on the bottom. So my x is talking about weeks, and my y value is talking about money. So I'm able to label, and then we have to put the values on. My x's are going to go up by 1, so that's pretty easy. Just like last time, I'm going to skip a row in between. So I have 1, 2, 3, 4, 5, and 6. But then when I try to number my y's, if I count by 5s like I did last time, it's going to give me 10, 20, 30. All my points are going to be crammed in like this. I'm not going to be able to see much on that graph, and it's going to be really hard to figure out. So what we can do to make it a little more graphing friendly is we can put a jump in our graph. And so I don't really need to start counting till 20, and then I'm going to count slowly once I get there. So what we can do is we do a little zigzag, almost like a heartbeat line, over a few spaces, and then we say we're starting our graph at 20. So this shows we skipped numbers, and we're going to start counting from 20 and then count up from there. You see this a lot in science classes. If your graph doesn't start till 300 with the data, you're going to skip 1 through 300 before you start graphing. You're kind of zooming in on a spot. And then from there, I'm going to count up by dollars, since I'm going up only by $1.50 each time. So then I would have 21, 22, 23, 24, 25, 26, 27, 28, and I'm going to just go up to $30. So I'm counting by whole dollars on each line just to make it a little easier for graphing purposes. Now we're ready to graph. I start at $20, so 0, 20. After 1 week, I have $21.50, which will be right there. 2 weeks, I'm up to $23. 3 weeks is $24.50. 4 weeks is $26. After 5 weeks, I have another $1.50, so I'm $27.50. And after 6 weeks, I'm at $29. I can go ahead and connect my dots in that line. If it's not straight, you know you made a mistake, because we're working with linear graphs. Now I have a graph that's kind of zoomed in. It's much easier to see for these values that I'm given because I was able to do this jump. So make note of that. It's really helpful to have that ability.